Alright, all of these at the top of this page are solved, and at actually 21 through 23 as well, are solved a little differently. This I need to always factor first if it's a trinomial, and the factors of 20 that, or of, excuse me, 40 that will give me 18 are negative 20 and positive 2. So I'm going to set each one of these equal to 0 and do the opposite to solve. So add 20 here, minus 2 there, that's how I get my two answers. In this problem, I need to minus 24x to both sides. Those cancel. 8x squared minus 24x equals 0. And then this is a GCF problem. The biggest number I can take out of both those is 8. I can also take an x out. I'm left with x minus 3. That doesn't go away. I need both of these to set equal to 0, which in this case, I just get 0. And in this case, I get 3. Okay. On number 20, I need to solve it for x squared. This is, again, a little different, so I'm going to add 20 to both sides. X squared equals 20, and square root it. This becomes 4 and 5, which is plus or minus, because I took a square root, 2 square roots of 5. Okay. Down at the bottom, again, all these are a little bit different. I need to get all of this to one side. So I get 8x squared plus 6x plus 1 equals 0. I'm going to factor that now. I know I got 1 and 1. I got x and x. And the factors end up being 2 and 4, not 8 and 1, because I need them to add up to 6. 2x plus 1 equals 0. 4x plus 1 equals 0, and I'm going to do this pretty fast. There's my two answers, negative 1/2 and negative 1/4. Okay. This right here, I need to minus the 75 to both sides. 3x squared equals negative 75. And x squared equals negative 25, and of course square root it. Excuse me, x equals plus or minus 5i. Again, because this is square root of 25 and square root of negative 1. This is a GCF problem set up for us, just like, now look at how similar these two were, and how similar these two are. This is already set up for us, so I can GCF a 3x out of both of those. I'd be left with x plus 25, and I set each factor equal to 0. That's how I get 0 and negative 25. Okay. Down at the bottom, I got a couple of quadratic equations that I need to use the quadratic formula, but to do that I need to add 2 to both sides here first, like so. Then I need to identify what A, B, and C are. Now just plug them in. The negative 3 is positive 3 plus or minus the square root of negative 3 squared minus 4 times 2. Well, let's write it. Some people don't write the square root under the whole thing. Some people try and plug in different things. Remember that every time you square this, you're going to get a positive number there. 3 plus or minus the square root of 9 minus 16 times 2 is 32. Which is, just dawned on me, you might not be able to see all of this, negative 23, which reduces to, well, I can take the I out of there, and the rest stays put, because I can't break that up into 4 or 9 or 16, so there's my answer, done. Now in this one, let's say, okay, A is 2, B is negative 9, C is negative 5, let's plug it in. Again, the opposite of B is 9 plus or minus the square root. Negative 9 squared minus 4 times 2 times negative 5. (81) plus, because I got a negative times a negative, 8 times 5 is 40, which becomes 9 plus or minus the square root of 121 over 4, and we can do that. That's 11. So this becomes, again, 9 plus 11 over 4, and 9 minus 11 over 4, which gives me 20 over 4, which is 5, negative 2 over 4, which reduces to negative 1/2. Yes, we will take a half point off if you do not reduce it, if it can be. What I want you to recognize is you're going to see one of each of these on the test. You're going to see one that has an I in the answer, and you're going to see one that works out to where you can get whole numbers or fractions. There's page 4, one more to go.